Section 8.6 is on solving rational equations and inequalities. A rational equation is an equation that contains one or more rational expressions. In order to solve a rational equation, we want to multiply the entire equation by the least common denominator. This will cancel out the denominators and leave us with just a plain old equation, very straightforward and pretty easy to solve. Let's take a look at some examples here. Our first one is 7 over 12 plus 9 over x minus 4 equals 55 over 48. First thing I need to do is figure out what is my least common denominator. So that's going to be 48 and an x minus 4. So what I need to do is multiply the entire equation by that common denominator. 48 times x minus 4. And if it helps, you can think of it as being that over 1. And what this will do is it's going to cancel the different parts of our denominator. So I have 7 over 12 times 48 times x minus 4 over 1. The 12 and the 48 cancel. Well, I'll still have my 7. 12 and 48 cancel and leave me with a 4 and an x minus 4. Now when I multiply my second fraction here, the x minus 4's cancel out and I have 9 times 48. And then when I distribute to my fraction 55 over 48, my 48's cancel, and I have 55 times x minus 4. Now that's a much nicer looking equation. So when I distribute here, so this is going to be a 28, that's going to give me 28x minus 112, that's 28 times 4, plus 432 equals 55x minus 220. Solving that and moving all of my x's to the left, I get negative 27x equals, and then moving these terms to the right, negative 540. So x is equal to 20. Whoops, sorry about that. Now to check that, I'm going to plug that back into the original equation. So is 7 over 12 plus 9 over 20 minus 4 equal to 55 over 48. And plugging each side into my calculator, I get that 1.1458 ... goes on forever is indeed equal to, we have the same thing on the other side. So if you end up with kind of messy fractions or whatever, just go ahead and plug it into your calculator. So it does indeed work. So my answer equals 20. Here's another example. 7x over 3x plus 3 minus 5 over 4x minus 4 equals 3 over 2x plus 2. So in order to find my common denominator, I'm going to have to factor each one of these. So this is going to factor into 3 times x plus 1. This is going to factor into 4 times x minus 1, and this is going to factor into 2 times x plus 1. So my common denominator, so if I'm looking at the 3, 4, and the 2, that's going to give me a 12, and then I'll need to have an x plus 1 and an x minus 1. Okay, so let's go ahead and multiply our entire denominator. I think I'm going to cross those out so I don't get confused. I factored each one of those. Multiply that by 12 times an x plus 1 and an x minus 1. Put it over 1 if you'd like, and distribute that 3 times. So I will have my original 7x on the top. The 12 and the 3 are going to cancel and leave me with a 4 on top. And the x plus 1's will cancel, and I'll have an x minus 1 left. And then doing my second distribution, the 4 and the 12 will cancel and leave me with a 3. X minus 1's will cancel and leave me with an x plus 1. And then my last distribution, 12 and 2 will cancel and leave me with a 6. And the x plus 1's cancel, leave me with an x minus 1. Okay, a little messy, but not too bad. So this is going to give me 28x, and when I distribute that, that's going to give me a 28x squared minus 28x. and then negative 15 distributed to that is a negative 15x plus minus 15. And this is going to give me an 18x. Oh dear, I copied the problem wrong. There should have been an x up there. My mistake. Sorry about that. Did you see that? There should have been a 3. That should have been a 3x on the top. So let me go ahead and change this. So when I did that last distribution, I would have had a 3x times the 6 times the x minus 1, which did not cancel. Sorry about that. So that gives me an 18x squared minus 18x. Okay, so this is going to be a quadratic equation. My x squareds are not going to cancel out, so I'm going to move everything to the left and make it equal 0. So that's going to give me a 10x squared minus 25x minus 15 equals 0. Doesn't look too bad. I'm going to go ahead and divide everything by 5 because I can do that. So it's going to give me a 2x squared minus 5x minus 3 equals 0. And then factoring that factors into 2x plus 1 and x minus 3. Oops. So that gives me that x equals a negative 1/2 and x equals 3. And I need to check each one of those. This is kind of a bother, but we do need to do it. First of all, it's really obvious, what can x not be? X cannot be any value that makes the denominator 0. So if I ended up with an x equals a negative 1 or an x equals a positive 1, I'd have to throw those out automatically, but that's not happening. So when I check, plugging in a negative 1/2 and using my calculator, I'm going to get negative 3.5 over 1.5 minus 5 over a negative 6. Is that equal to a negative 1.5 over 1? And indeed it is. That's going to be a negative 7/3 plus 5/6 is indeed equal to a negative 2/3. I'm sorry, 3 over 2. Negative 3 over 2. And that one does check. And I used my calculator heavily for that. Let's check. Checking with 3 is going to give me 21 over 12 minus 5 over 8. Is that equal to 9 over 8? And that comes out to a 1.125. Is indeed equal to a 1.125. So both of my solutions check. Now, to solve a rational inequality, so this is going to look like a rational equation, but it's going to have a greater than or less than sign in there. Here are the steps you need to follow. Find the excluded values, in other words, what can x not be? What values of x are going to make the denominator 0? We solve the related equation. Solve it as though it was just an equal sign instead of a greater than or less than, and then use the values from the first two steps to divide a number line into intervals, and then we need to test a value in each interval. So it's basically your solution is going to be most likely either an and or an or inequality. Let's take a look at a couple examples. So here we have 5 over x plus 6 over 5x is greater than 2/3. So my excluded values would be x cannot equal 0. So that's going to be one of the numbers on my number line. Actually, let me move that over here a little bit so I have some room for my common denominator. My common denominator would be a 15x. So I'm going to go ahead and solve this as though it were an equation. So like a 15x over 1. And then distributing my x's, my first distribution, my x's will cancel, and I'll have 5 times 15. With my second distribution, my x's will cancel, and that'll give me a 6 times a 3. And I'm going to switch over to an equal sign here just so we can get the numbers here. And then my last canceling, it's going to give me a 2 times a 5x. So just go ahead and solve that. 75 plus 18 equals 10x. 93 is equal to 10x, or x equals 9. Let me make that a little neater here. X equals 9.3. So these are the two values I'm going to put on the number line, my 0 and my 9.3. So let's draw the number line, 0, 9.3, and as you can see, this divides the number line into three intervals. That which is less than 0, that area that is between 0 and 9.3, and the area greater than 9.3. So I need to try a point in each area in the original inequality. So I'm going to pick an easy one over here, let x equal -1. So when I plug in -1 for x, I'll get -5 plus 6 over -5. Is that greater than 2/3? And using my calculator, I get -6.2 is greater than 2/3 is approximately 0.6 repeating. That is not greater, so this region would be a no. So the values don't work in there. Now I'm going to pick a value between 0 and 9.3. I'm going to pick x equals 1 and try that. Plugging that back into my original inequality, is 5 plus 6 over 5 greater than 2/3? This gives me 6.2, and that is indeed greater than 0.6 repeating. So yes, that area does work. And then I'll pick a number that is greater than 9.3. I chose x equals 10. Plugging in 10 for x, I get 1/2 plus 6 over 50. Is that greater than 2/3? That gives me 0.62, and that is not greater than 0.6 repeating, so this region would be a no. So my final answer is just this interval between 0 and 9.3. So I write my answer like this: 0 is less than x, which is less than 9.3. And it's not an or equal to because my original inequality was not an or equal to. Let's take a look at one more example here. Here I have 4 over 3x plus 7 over x is less than 5/9. So my excluded values, x cannot equal 0. So that's going to be one of the values I put on my number line. And now my common denominator is going to be 9x. So let's multiply everything by 9x over 1. And that's going to give me a 4 times 3 plus 7 times 9. I'll go ahead and write out the steps here. I'm going to switch this over to an equal sign. My 9's will cancel, and that leaves me with 5x. So 12 plus 63 is equal to 5x. 75 equals 5x, or x is equal to 15. So these are the two values I'm going to put on my number line. 0 and 15. So now I need to check a point in each of those regions. So I'll start by trying x equals -1. Plugging that back into the original inequality is going to give me a -4/3. Minus 7, is that less than 5/9? And using my calculator, I got -8.3 repeating is less than 5/9. 5/9 is a positive number, so any negative number is going to be less than that. So that interval works. That's a yes. In the region in between here, I chose x equals 1. So that's going to give me 4/3 plus 7. Is that less than 5/9? No, that gives me about 8.3. And that is not less than 5/9 because 5/9 is less than 1. So that region is a no. And then choosing a number greater than 15, I chose 20. You can choose anything you'd like. Plugging that in is going to give me 4 over 60 plus 7 over 20. Is that less than 5/9? This gives me 0.416 repeating is less than 5/9. I figured that out is 0.5 repeating, so that is indeed true. That is a smaller number, so this interval is yes. So my final answer is going to be an OR inequality, anything that's less than 0 or anything that is greater than 15. So x is less than 0 or x is greater than 15. So in this section, we took a look at solving rational equations and inequalities. Unfortunately, they are kind of a little difficult because it involves a lot of work. Rational equations need to be checked. You need to check your solutions. Please use your calculator. And rational inequalities, once you get your solution, you do need to check the intervals on the number line.